What we're going to do now is we're going to take a tour through some of the key methods that are defined in the Java ReentrantLock class. And of course, as you may have already surmised, its key methods lock and unlock. But there's a few more things and a few more subtleties that you need to be aware of in order to use locks correctly, ReentrantLocks correctly in Java. As always, you can take a look at the source code because it's available in open source form on the web. All the methods we're going to look at are actually defined in the lock interface that ReentrantLock implements. The method implementations, as you can see here, all simply forward to internal methods that are part of the sync hierarchy, which will either be fair sync or non-fair sync. And fair sync and non-fair syncs methods in turn largely inherit their behavior from the abstract queued synchronizer framework. So you can see here when lock is called, it calls sync lock. When lock interruptibly is called, it calls sync acquire interruptibly with a count of 1. When try lock is called, it calls sync non-fair try acquire with a count of 1. And when unlock is called, it calls release with a count of 1. And may come as no surprise that these methods like release and non-fair try acquire and so on are also used by other synchronizers that are part of the Java util concurrent locks package. Things like Reentrant read-write lock, as well as other locks in Java util concurrent like semaphore. The lock method tries to acquire the lock, not tries to acquire, will block until it acquires the lock if it's available. And if the lock isn't available, then the behavior of the implementation depends on the fairness policy. So non-fair implementations are optimized in hardware, and they can do all kinds of clever things like spin locks, whereas the fair implementations park themselves on a wait queue in strict FIFO order. And so the order in which you get the lock depends on the order in which you arrived. Kind of like when you make a call to a call center and they say, calls are answered in the order received, so please don't hang up and call back. A lock call by itself, just the lock method that's inherited from lock, the lock interface, is not interruptible, so it can't be disturbed. So that is basically the same semantics as Java's built-in monitor object synchronized methods and statements. Those locks are also not interruptible, as we saw before. Therefore, if you want interruptibility, you need to call lock interruptibly. That's an alternative method also defined in the lock interface, and that will be able to return and throw the interrupted exception if someone sets the interrupted flag, if some other thread sets the interrupted flag while it's running. That is different from what you get with built-in monitor object synchronized statements and methods. They don't have the interruptibility property. And we'll talk more about this later. Try lock acquires a lock if and only if it's not already held by another thread at the time that it's invoked. And one of the interesting things about this is even if you have set the lock semantics to be fair and you call try lock with no parameters, it will barge ahead and try to get the lock irrespective of fairness, which is kind of a weird thing, but we'll talk about why that is when we talk about the timeout versions of try lock. So always remember that try lock will barge, in other words, cut ahead if it can, and not obey the fairness settings. Unlock attempts to release the lock. And as you can see, it calls the release method that's defined in the abstract queued synchronizer class. And much like our spin lock implementation that we did for assignment 1B, this will throw the illegal monitor state exception if the thread that's unlocking the lock doesn't hold the lock or doesn't own the lock. So that'll throw it if you do this, if you use the protocol incorrectly. So another way of thinking about this is that a ReentrantLock is intended to be used in a fully bracketed manner, meaning the thread that acquires it must be the thread to release it. Now, if the hold count is greater than 1, then the lock is not released. The hold count is simply decremented by 1. And that, of course, is the semantics that are given by virtue of the fact that ReentrantLock is a reentrant mutex. Now, it turns out that there's also a bunch of other ReentrantLock methods that do things well above and beyond what you get with kind of the classic Java synchronized statement and synchronized block. So here are some of the interesting methods. There's actually a whole bunch more that we're not going to talk about, but these are the key ones. So there's a try lock method that's got a timeout property built in. So you can say, I will try to acquire the lock and I'm willing to wait up to X amount of time, where that's a timeout in a time unit, like 1 second or 10 seconds or 10 milliseconds or whatever you want. And the interesting thing about the try lock that's timed is it does, in fact, honor the fairness setting and therefore doesn't barge ahead. It waits its turn. There's also a method called isFair that returns whether or not this is a fair lock with fair semantics. There's a method called isLocked that queries the lock to see if it's currently locked or not. This turns out to not really be all that useful in practice because by the time that isFair returns to you true or false, the lock state may have changed already because some other thread may have changed it. And then the last method, this is actually an important method. This is a factory method that creates a condition object that's associated with that particular lock. And when we talk about condition objects later in the course, you'll see how useful this is to create condition objects that are associated with a reentrant lock that can be used to guard their conditions against race conditions. So that's the end of the key methods in the Java ReentrantLock class. For the way you'll be using it in our assignment, you'll just be using a few of these methods, but it's important to understand how they all work. And it's also important to understand the richness of the ReentrantLock interface relative to the much more simple and more optimized version that comes with Java's synchronized methods and synchronized statements, which use the so-called monitor lock or intrinsic lock that comes with Java's built-in monitor objects.